We look up at Saturn and see a distant, almost alien beauty defined by its iconic halo of ice. But about 466 million years ago, if you looked at Earth from a distance, you would have seen something strikingly similar. During a stretch of time called the Ordovician period, our own planet likely possessed a massive, sprawling ring system. When a large asteroid flies too close to Earth, it crosses a gravitational threshold called the Roche limit. At this specific distance, tidal forces overwhelm the asteroid's structural integrity, ripping it apart into a vast debris field. Because Earth sits much closer to the Sun than Saturn does, any ice in that debris would have quickly vaporized. What remained was a dense, swirling band made entirely of pulverized rock and dust. This ancient ring was a violent, temporary scar left behind by a cosmic near miss. All that rocky debris didn't stay safely in orbit. Over millions of years, chunks of it steadily rained down, creating a highly concentrated zone of meteorite bombardment exclusively along Earth's equator. This dense band of orbiting rock cast a massive shadow over the planet, blocking crucial sunlight. This lack of solar radiation correlates with the Hirnantian Icehouse, triggering severe global temperature drops and one of the most extreme freezes in 500 million years. A planetary ring acts as a massive climate disruptor, capable of plunging the world below it into an ice age. If that ring system had survived into the human era, its visual impact on early civilizations would be entirely dictated by geographic latitude. Standing directly on the equator, in a place like Quito, Ecuador, the view is completely edge-on. The ring would appear as a razor-thin, brilliantly bright line rising straight up and bisecting the sky. Move north to the mid-latitudes, and the perspective shifts dramatically. From the steps of the U.S. Capitol, civilizations would look up to see a massive arch spanning entirely from horizon to horizon. But that majestic arch carries a dark side. As the Earth tilts through its seasons, the ring's immense shadow would shift across the hemispheres, plunging the winter half of the globe into extended periods of extreme cold and darkness. Lacking telescopes to understand these orbital mechanics, early cultures would likely interpret the creeping shadow as a malevolent cosmic serpent devouring the sun's warmth, driving complex religious sacrifices and rituals to bring the light back. The looming presence of the ring would hardwire human religion and culture around the terrifying, highly visible mechanics of the solar system. Yet, as civilizations began sailing the oceans and mapping the globe, the ring would take on a completely different role. Historically, sailors struggled for centuries to calculate their exact longitude at sea, leading to lost ships and inaccurate maps. A permanent celestial ring would solve this geographical crisis immediately. Look at this schematic of the rings. See those small highlighted dots? They represent shepherd moons, tiny satellites orbiting within the debris fields. Because they move along the ring tracks at measurable, predictable intervals, they act exactly like the moving hands of a cosmic clock, giving sailors perfect global timekeeping. Beyond tracking those moons, navigators could also measure the exact, predictable movement of Earth's shadow across the brightly lit face of the ring itself. By comparing the shadow's position to the local time, a ship could pinpoint its exact coordinates on the globe. By providing a constant, reliable reference for time and position, these rings would have compressed the timeline of global exploration, pushing trade forward by centuries. Move to the modern era, and those historical navigation benefits evaporate, replaced by an insurmountable nightmare for aerospace engineering. The physical reality of the ring plane is that it's a chaotic, high-velocity blender of rock, dust, and debris. Any attempt to launch rockets through that equatorial band would mean flying directly into a buzzsaw. While deep undersea cables would function just fine for communication, the fragile orbital technology we rely on today wouldn't survive. GPS networks, weather monitors, and low Earth orbit satellites would be shredded by the debris field.
The structure that accelerated early human exploration across the oceans would actively prevent our technological expansion into space. We can trace the path of this theoretical ring from a violent geological birth to an object of religious terror to the ultimate navigational tool. Today, we look up at a clear, open sky that invites us to explore the wider cosmos. A ringed Earth presents a completely different, highly restricted reality. A civilization born under these rings would likely master the geography of their world long before the industrial era, ocean-spanning and connected, yet forever trapped on their home world. Earth's rings would have traded our access to the stars for a beautiful, inescapable cage.